Hello, everyone, and welcome to yet another episode of The Cloud Show. Of course, we have a new guest today, and it's going to be an interesting conversation about a very hot topic, which is complicated for many, and people feel like, oh my God, there's so much I need to learn. Fortunately, we have a star of the show who knows all about AI or the trends sort of shaping the future of AI, rather. That's what we're going to talk about, 3 different trends today. And I'm going to do that together with a good friend of mine, Mr. Rene Schulte. Hello, my friend. Welcome to the Cloud Show.
Hey, Magnus, thanks for having me.
Absolutely, my pleasure. It's great to talk to you. We saw each other just a couple of weeks ago.
Yeah, it feels like yesterday, but it's been like 4 weeks, 3 weeks,
Yeah,
something.
I know. Time flies. It does. But it was good to see you in the same physical space. But right now you're not in this physical space in my home office. You are in what? Your home office?
Yeah, it's my home office in Dresden, in Germany.
In Germany. All right. So
Yeah,
for the audience, tell us a little bit about yourself and what you do.
sure. So my name is Rene. I work for a company called Reply. We're a system integrator, 16,000 employees worldwide, and quite a bit of revenue. Not a lot of folks know us. That's why I talk about it. But mainly headquartered in Italy, but also a big presence in Germany, and actually also in the US. We have 1,000 people or so. What I do
Okay.
is I work for our CTO, and I manage multiple groups, which we call communities of practices, and they work on innovative topics. And my teams are digital human, synthetic data, general AI, spatial computing, and quantum and future of computing. So all the fun, great topics.
Wow.
And I enjoy this because working with a lot of smart young folks, and doing some fun stuff in the end, but also some good bleeding edge stuff there. I'm
Yeah.
also a content creator, making a bunch of stuff like we all do on social media. But also have my own podcast. Shameless plug here, Digital Dialogues. If you
Go
want
for
to
it.
check this out,
That's okay.
we're right now
We're all a
talking.
big family.
Yeah, we're right now talking with lots of experts in humanoid robotics. So if that is your thing, you
Wow.
might want to check this out. And
Totally.
yeah, what else? MVP and Microsoft Regional Director, just like you,
Yeah.
Magnus, and all these other
Absolutely.
things we do, right? It's like,
All these things we do. All right, we keep hanging out together. That's for sure, and I like that a lot.
yeah,
So, all right, cool. So now we know a little bit about you. So you just picked the easiest teams to lead. I mean, just the simple topics, no complicated anything at all in the stuff that you do in business, right? Like quantum or easy stuff.
easy stuff where you always, I keep on saying it's the bleeding edge, and sometimes we really bleed on the edge. I
That's
guess
for
that's
sure.
where it comes from.
That's
And
exactly
also,
you know where that comes from.
yeah, and you know what's
Yeah,
the
no.
challenge also is like these days when we talk about AI and vibe coding and all the good stuff,
Mm,
um, there's not a lot of data for these topics available, which these models could have been trained on. So it's
mm.
still untouched field. So sometimes you
Early
really have.
days in some areas, yeah, for sure. The bleeding edge, the front line where things happen. And so one of those things that has been happening for quite a while now is AI. And I'm sure a lot of people are confused about what's going on and like where is this going and what is that front line, the edge, and where is the trend
Yeah.
in this space, right? The future of AI. You gave me this wonderful topic to talk about today. You said, hey, let's talk about the 3 key trends shaping the future of AI. I was like, that sounds really impressive. Let's talk about
Yeah.
that. Right?
Great. Let's do this.
Yeah.
If we, of course, everyone might have a different view on this, but like from the work I'm doing, like these 3 trends clearly emerge. But let me give you an intro to this first. I think like when we look at AI and as in particular the applied usage of AI, I think the 2 biggest transformative applied use cases will be one, computer use agents. So basically AI agents that control your computer in the end. So think
Mhm.
about, you can give it an old let's say, WinForms application or some complicated ERP system no one really understands how to use. And so you can apply a computer use agent and it will automatically, learn how to do this and basically fulfill a task on behalf of you. And that will be a big transformative automation in office work for sure. It will be massive, right? If you think about business process outsourcing and similar kind of things, like that might actually be, changing from like a near shoring or shoring into a silicon shoring, right? Where you leverage agents and you control these agentic systems. So that's one part, the computer use agents, right? And the second is likely humanoid robotics and humanoid robots. We might see them first in factories, but like in the next decade, I'm pretty optimistic that we will see them, around us pretty much. I keep on joking, right? In Germany, we might still use fax machines. By 2030, when the rest of the world employs humanoid robotics. But maybe the final grand Turing test is when we get a humanoid robot to actually operate a fax machine. I don't know. Maybe that's.
We'll see. We'll see. Yeah, yeah. No, so it's that when we see robots doing things in our environment autonomously, is that going to be a really bad day for everyone who drives deliveries, or what's going to happen, you think?
That's a common theme, and I think also there's a misconception coming from especially science fiction movies. They ruined the perception of a lot of people, right? When you hear about robots, you immediately see the Terminator intro scene in your head,
right? And you think iRobot or something like that.
Exactly. Oh, iRobot and all these crazy movies, right? Where it's always the bad, and so. That is the perception a lot of folks are having, and that is not going to happen. And also, they will not replace humans, but we are facing a challenge. If you look at the market, and I was just talking with a professor from Italy that is very in depth with humanoid robotics, and he was basically saying it's not just the Western world. We see the decline of birth rate now happening in a lot of places in the world, and that actually means we don't have enough workforce. So who's going to do the delivery driving?
That's right.
They're already, like, I don't know how it is in Sweden or the rest of the world, but for sure here in Germany, it's like truck drivers, like they're looking for truck driver jobs all over the place. They cannot even find enough of them, right? So it's just going to, fulfill the gap basically, and it's going to allow us to scale. So that's
good.
what's going to happen. Right?
Yeah, no, it might mean that some things will change, but likely the opportunities for doing something is not going to go away. You're not going to be replaced by a silicon chip. That's not how it works. It might take over some work task that you used to do, maybe, but you will do something else. It's not like it's a threat.
That's exactly the right way to look at it. And in the end, these are waves of automation, right? We also had in the past, right? There's multiple waves of automation. The difference now is it goes really fast, and that's the challenge we're facing, right? People need to adapt to this new modern work world, and that is a challenge. And so I think the biggest challenge is actually the cultural shift, indeed, that you mentioned, right? But we got to support everyone and take everyone with us. Like my recommendation always when I do talks and so on is, like, since I don't know a couple of years, I always keep on saying to folks, like, try out these services, try out these tools, experiment with those, because one thing is for sure, like, if you have no clue about AI tools, if you're if you're simply not interested in that and say, well, this is just going to go away, then you're in the same position like the folks in the 90s when they said, oh, the internet is just a thing that's going to go away, right? That's not going to happen. Like, this is here to stay, and if you want to be relevant in the market, you gotta upskill yourself in that field. That's for sure.
Yeah, no, for sure. No, I totally agree, and that's why change is scary for some people, and we already know that. So let's try to kind of look forward on these. You were saying three things, right?
Yeah. Yes. So let's dive into each of those, right? We have multi-model models, and this is the first big trend we're seeing right now. Everyone knows generative AI, right? It's a subcategory of neural networks in the end that generate content, and they generate, language models like the ChatGPTs of the world. They generate text, and of course, you have other models that generate images and so on. And now we also have models that can not only generate images, but they can also have vision. They have vision capabilities, so they can also kind of understand these images that you're passing in. And if we take
Send them an image and say, use this image and create, me flying in an airplane or something.
Exactly. And that's what we have seen with the latest GPT-4 image generation, which is pretty interesting in itself from a technical standpoint, because they're using a different approach than all these other image generation models, like, Stable Diffusion, Midjourney, DALL-E, and so on. They use what is called diffusion method. And LLMs, they are autoregressive models, transformer architectures behind this. And if you use the GPT-4 image generation, it actually does not use a diffusion model to generate the image, but it also does it autoregressively. So instead of text token by token, it's pixels by pixels. And that's why you get much better consistency in the GPT-4 image generation. Also, when you say, hey, take this image and put me into a plane, you really get reassembled, right? Try to do this with a diffusion model, much, much harder. And that's the beauty of this auto-regression, but it also takes longer then, right? So it's always a kind of trade-off there. But what I wanted to say is these are multi-model models. Like true multi-model models can interpret and generate content across different multiple modalities. So image, text, audio, video, and so on. And the really good ones, they actually have so-called joint embeddings. What that means is when you train that model with these text tokens, you, for example, if you also want to do a real-time audio model, you basically give the same audio snippet with it, right? So internally, that model learns then text snippet, combined to the audio snippet. And that's how these real-time audio models work. Like if you're using Gemini from Google or GPT from OpenAI, if you have the mobile app, you have this like real-time audio conversation. That's only possible with these true multi-model models, right? So different data types in, different data types out. That's multimodality. And we're really just at the beginning. There's a research from Switzerland, some university there. They have 24 different modalities. Like I could not even come up with what are 24 different modalities, right? But apparently there are so many, like depth data, and all these spectral image data and what have you, right? There's all these different stuff.
Okay. That's more than I know.
Yeah, I was like, what, 24? Like, what could it be? I could probably come up with 10 or so, but hey, what do I know? And that is multimodality. So different input types in, and also you can generate different output types. That's very important for these models to then also understand the world. And what we're also seeing is, of course, you don't just use a single model, but you use actually multiple instances. Even it could be the same model or could also be different models, because some of these language models have certain specifics what they're trained for. Like some are very good at math or coding. Others are very good at copy, text copy writing, that kind of stuff. And when you combine those, you end up with a multi-agent system. And what an agent, like you have multiple levels there with agents, right? The first experience is basically you're using a chat interface and you have an assistant kind of a thing. The next level is then a single agent where you have one model, but you give it a specific role, if you will, right? And you give it also data, contextual data. And so, for example, we created an agent for RFPs, right? Who likes to answer RFPs? Of course, we have to do it, but no one likes that. So we created an agent that is very good and has contextual data for RFPs, like requests for proposals, right? Like if you're not familiar with what RFP is. And that basically helps a lot. And it's very specifically configured for that task. So that's a single agent. And if we take then a single agent and actually make multiple versions of it, or like other agents, then we have a multi-agent system. And that's where it really becomes interesting. So one example is take a software project, right? Like a software development project. You have all these different roles. You have software developer, you have QA analyst, you have project manager, you have business analyst, whatever, right? Depends always on the project and the clients. But you have all these different roles. Now imagine like each of these roles becomes an agent, and you as a developer, actually, you are orchestrating a team of agents. And that's what the shift a lot of folks need to make mentally, right? Like developers will still be needed, that's for sure. But instead of writing lots of lines of code, you will be an orchestrator. You will be rather a technical program manager of an agentic team. And the crazy part is also you can apply this to whole organizations, right? like your whole company organizational structure, you can think about like, how can I implement agentic teams in different roles?
Wow.
And that's going to be a massive shift, actually.
Oh yeah. All right. So we're going for that, and there was another trend about synthetic data,
Synthetic
right?
data. Yes,
Yeah.
yes, synthetic data. And that is becoming interesting for a couple of points. So first of all, if you listen to one of the latest OpenAI podcasts with Sam Altman and some of his colleagues, they actually mentioned a quite interesting thing, that the development of the novel language models is not so much limited by the compute power anymore, right? They say there's enough compute power available for them. What they're rather limited is, which is surprising, what they're rather limited on is data. And most of the models are data bound because they use so much data to train these models, and they're kind of reaching a peak, with the available data they can use. And so what some companies are doing, and Microsoft is very good there with the Phi-4 model, or as our US colleagues would say, Phi-4, but the Greek letter Phi. And basically that model, but also Google with Gemma, what they are leveraging also a lot of synthetic data to actually train the models. So instead
Right.
of using data from the real world, they're actually taking some little data samples from the real world and then augment it with synthetic data. So with artificially generated data. And that could be textual data, but it could also be visual data. And that's where it's also becoming interesting when we talk about the other trend about embodied intelligence or physical AI, thinking about robotics, like synthetic data. Let me give you a bunch of examples before we dive into the robotics aspect. But one
Yeah.
case where we leveraged synthetic data was with healthcare data. And as
Yeah.
you know, it's of course very sensitive data, right? Patient data. You don't want
Yes, of
to
course.
actually leverage the real data too much, or just use a small set of that. And of course, what you lose if you then train a model on that, you lose a lot of generalization, because if you don't have enough data, the model will not be good. So
Right.
what you leverage then is certain algorithms where you can take a very small data set and augment and expand this into with a higher diversity, and you get a higher variance in the end from the statistical standpoint, which means your model will generalize much better. And that's what we actually did with synthetic medical document generation. And we got like what is it? I have the slide here. It's like 3 times higher variance, right? So 3 times better generalization by just using existing data and augmenting this, like adding more stuff. So that's pretty interesting, I think, from the classic tabular textual machine learning data.
Yeah.
But even more interesting, I think, is it when we think about the application of synthetic data for computer vision and also for robotics scenarios. So NVIDIA, for example, is pretty prominent there in the space with NVIDIA Omniverse, where they provide you kind of simulation environment. And we're also working with clients. For example, we're replicating warehouses or
Yeah.
simulating certain stations, certain packaging stations in the warehouse, and so on. And we do this in order to identify. Let me make it more practical. So there's a case with a client. They need to load a pallet. They produce goods and they need to put boxes on a pallet,
On a
and then
pallet. Yeah.
they ship it out. So usual use case. And of course, the pallet loading is done by robotic arm, right? There's no human
Of course.
putting a box
Yes.
on the pallet. And so,
No
but
humans on the
sometimes,
factory floor.
well, there's still a lot of humans there for sure, but like, who wants to? I mean, these are heavy goods, right? So it's good from
Yeah.
ergonomic
Right.
standpoint. It's like they don't need to take the heavy boxes and put it on the pallet. The issue only becomes is sometimes the robot makes mistakes and puts the boxes on the wrong order or something, which means then if then someone comes in with a forklift and picks it up, it might fall over, and that is expensive with the goods, right? Easily 100K broken stuff or so, and it only happens every few weeks or months. And that's a challenge, because how would you detect this? You don't have the real world data available to train your model. So what we are doing is we're simulating the whole thing in a 3D environment, and then we can simulate all the different variations you can imagine. We can render a million different permutations out of this, with different light, with different shading, different
Interesting.
backgrounds, and all of this. And this is the data we then use to train a computer vision model, which will then detect the issue before it's too late. And that is one case. Another one is also, if you think about like dangerous locations, think about a mine, right? Like a coal mine or whatever,
Yeah.
right? Where miners are inside. Imagine if there's a fire happening, right? And you want to send in a robot. and the robot needs to navigate and needs to know the way and so on. It's very hard to simulate to have this training data on the real world, right? When there's a fire in the mine, like when would you get training data?
You don't have a million fires to with real data. You have to, right?
Exactly. Yeah,
that would be bad if you had a million fires.
That would be really bad, especially.
But you would have enough data to train your AI on it. That would be good, but it would be terrible to have a million fires.
Yeah, exactly. So don't do this. What rather do is leverage also Unreal Engine, right, or other like 3D rendering, methodologies these days. If you look at some of the stuff, if you look at some of the games you probably have seen, it's incredible, like the quality of 3D rendering. Of course. And so what we can do is we can send a robot once into the mine with a laser scanner, and it does a 3D scan of the environment. And then we take this 3D scan, put it in Unreal or whatever, or Omniverse, doesn't matter. And then we add artificial smoke or artificial fire and all of this, and all different variations you can imagine.
So it's all fake. But the AI is trained on this generated synthetic data.
Exactly. And then we have the trained model, and then we take this, and this is called sim to real. So we do a simulation first, and then we deploy it on the real robotic system. And then, of course, that's the final real test, if it actually works, if it was trained well. But that's a lot of the methodologies we see these days. It's also called robotics gyms. Just if you go to the gym to train, right, you can have these robotic systems actually train in these Omniverse or other environments.
Very cool.
And that's when we come into embodied intelligence, right?
That's right. So it's like the next next thing, or like out of the three we're talking about today. So let's finish off strong on embodied intelligence. Then what are we talking about now?
Yeah, exactly. So that's the point where we take this synthetic data, for example, and train a robotic system. And that's where we have embodied intelligence or physical AI, right? We have these novel AI algorithms, these novel AI services now applied into an embodiment. And that could be a quadrupled, a four-legged robot like the Boston Dynamics Spot, or a humanoid robot. We also have one of those, like a bipedal robot that walks like a human. And so we leverage synthetic data also to train these ones and then to apply it. So that's one part of the physical AI. One part of the embodied intelligence is the physical embodiment. The other one is a digital embodiment, where I have an avatar, a digital human, like I give a face to a chatbot, if you will. But I can also attach to this effective computing, which we're also working on. Think about you giving it a personality. It's actually a fun anecdote. You probably know the Inside Out movie, right? This famous animated movie. And like the girl there, she has 8 emotions in her head. And actually, these 8 emotions, they did not just come up with that. That's actually based on a psychological model from an expert called Paul Ekman. And so that's the Paul Ekman model. We're actually leveraging the same model for our digital human. So 8 different emotions are firing. Each of them is an agent, multi-agent system. So let's say the fear or the surprise agent, they're getting an input from the user, and then they're firing, right? And then we have an orchestration agent, which then assembles the final answer. And then we have a system that reacts more empathetically and has more, sentiment and emotion, where you can, as a human, talk to and also feel more connected, I would say.
Wow, that's incredibly cool. You know what? Unfortunately, we are running out of time for this show. We could have talked about this for a longest time, but we'll stay true to form. It's a 20-minute show. So for the audience, this is where we cut Rene off this time. Thank you so much for being on the Cloud Show today. I appreciate it.
Thanks for having me, and take care, my friends. And don't worry, just make sure you look into AI services and stay up to date.
That's right. And I'll see you guys next time on the Cloud Show.
Bye-bye.